Therapies targeting the spike protein for prevention and management of COVID-19 have been granted Emergency Use Authorization, or EUA, by the U.S. Food and Drug Administration. These include COVID-19 vaccines and COVID-19 monoclonal antibody infusion therapies. New variants of SARS-CoV-2 have emerged with several mutations, including those in the receptor binding domain of the spike protein, and may affect the efficacy of these therapies. Changes in the structure of the spike protein can affect its binding affinity for the ACE2 receptor, which may increase viral transmission, load, and disease severity. One of the first variants of SARS-CoV-2 that was identified included a D614G mutation of the spike protein. This mutant virus, with glycine replacing aspartic acid at residue 614, is believed to spread more quickly than the original strain of COVID-19. Variants of concern that are now circulating nationwide in the United States include B117, known as the UK variant, B1351, the South African variant, P1, the variant from Brazil, and B1427 and B1429, both variant lineages from California. Mutations in the spike protein may also reduce the immune response induced by currently available vaccines directed at the spike protein. SARS-CoV-2 variants may also affect efficacy of EUA monoclonal antibody therapies directed at the spike protein. Use of two individual antibodies may prevent generation of escape mutants. Single-agent monoclonal antibody treatment is no longer recommended. The variant first identified in the United Kingdom was called a variant of concern of B117 lineage. It has multiple mutations in the spike glycoproteins gene. The N501Y mutation affects the conformation of the spike receptor binding domain and increases affinity for the ACE2 receptor. The deletion at positions 69 and 70 is believed to increase transmissibility. Pseudovirus neutralization data for SARS-CoV-2 variant substitutions show that variant B117 has minimal impact on neutralization by either of the monoclonal antibody cocktails currently authorized for emergency use, and appears to have minimal impact on vaccination. The South African variant, called 501V2 of B1351 lineage, shares some mutations with B117, including N501Y on the spike protein. Other mutations include E484K that may affect neutralization by some monoclonal antibodies and moderately reduce its efficacy against vaccination. The P1 variant that emerged from Brazil harbors the E484K and N501Y mutations in addition to K417N in the receptor binding domain of the spike protein. The K417N mutation reduces activity of single-agent monoclonal antibody, but dual-agent monoclonal antibodies retain the neutralization effect. P1 variants have reduced efficacy against vaccination. Two variants first identified in California are B1427 and B1429. They share two mutations that occur in the spike protein, L452R and D614G. The California variants have a significant lower response to some, but not all, EUA therapeutics. These variants also have moderately reduced neutralization by vaccination when tested in vitro. Scientists continue to monitor the spread of variants. Ongoing research aims to enhance the potency of monoclonal antibody therapies and vaccines against emerging SARS-CoV-2 variants.